Hello everybody! Today, very important lesson. I can set up trigonometric ratios using SOHCAHTOA. Very important lesson. And we're going to build off of this for the next couple weeks. So let's get right into it. There are three trig ratios that you need to be familiar with. Let me just get this thing writing here. And they're all based off of the acronym SOHCAHTOA. So helps you remember the formula. Sine of theta equals opposite over hypotenuse. Ta is an acronym for cosine of theta equals A adjacent over H hypotenuse. And TOA is an acronym for tan theta equals opposite over adjacent. So first off, what is this theta I keep on talking about? Theta. It is a Greek letter, and it's just a variable for the angle. Variable for angle. So like, we could use x, we can use any variable, but theta in this course and in math is generally always used for an angle. So saying sine of theta equals opposite over hypotenuse, it's just like saying sine of x equals opposite over hypotenuse, but theta is the variable we generally use when we're dealing with angles. I know you haven't seen it before, but you're seeing it now for the first time. Now let's talk about our opposite, our adjacent, and our hypotenuse. We talked in the last lesson, in the Pythagorean theorem lesson, that the hypotenuse is the long slanted side opposite the right angle. So that's never going to change. Now, the opposite and the adjacent will change depending on where the angle is. So if I'm working with this angle right here, let's talk about the word adjacent. In the English language, adjacent means next to. Which side is next to this angle? This side is. Adjacent is the side that's touching the angle. And the angle always attaches the hypotenuse and the adjacent. That's very important. The opposite side is the side that's opposite the angle, the side that's not touching it. Now, if I were to do the same exact picture, the hypotenuse never changes, the long slanted side never changes. But if I'm working with this angle now, well, which side is next to this angle? Which side is touching this angle? This one is. And this would become my opposite. So the adjacent and the opposite will change depending on which angle you're working with. The hypotenuse is always the hypotenuse, but whichever side is next to the angle you're working with is your adjacent. Whichever side is opposite the angle you're working with is the opposite. So here, if this is my angle, this is opposite. If this is my angle, this is opposite. So we did a lot of talking. Let's do some doing. I'm going to give you a right triangle. Let's call this X, Y, Z. Let's put some numbers in here. 3, 4, 5. I want sine of X. I want cosine of X. I want tangent of X. Well, I can write out my acronym, SOHCAHTOA. This is telling me again that the formula for sine is opposite over hypotenuse. This is telling me that the formula for cosine is adjacent over hypotenuse. This is telling me that the formula for tangent is opposite over adjacent. So my first step is to label my A, my O, and my H. So in this example, I'm working with angle X, so I'm going to draw a little arc in at angle X. I always start with my hypotenuse. The hypotenuse is my long slanted side opposite my right angle. My angle always connects my H to my A. And the side that's opposite this angle is my O. So now that I have those labeled, O over H would be 3 over 5. Done. Cosine is A over H. A over H is 4 over 5. Tangent is O over A. O over A is 3 over 4. That's it. Sine of x is 3 over 5. Cosine of x is 4 over 5. Tan of x is 3 over 4. Now, I want sine of z, cosine of z, tangent of z. So now I'm switching angles. So when I switch angles, my h is not going to change. The hypotenuse is still the hypotenuse. But if I switch to angle z now, that's going to change everything. So this is now my adjacent. This is now my opposite. So sine, the formula for sine is still over h. Cosine is a over h. Tangent is o over a. I just kind of lost my train of thought. My son just made his way down here. So now that I'm working with angle z, the angle always connects the h and the a. So this becomes my a, and this becomes my o. So when I switch angles, my a and my o will switch, but the h is still always the h. So for sine, o over h would be 4 over 5. For cosine, a over h would be 3 over 5. And for tangent, o over a would be 4 over 3. That's it. So, SOHCAHTOA is an acronym that gives you the 3 formulas for your trig functions. Sine of theta equals O over H. Cosine of theta equals A over H. Tan of theta equals O over A. I'm just going to write out the steps for you so you have them. They're in the front of your packet. But for trig ratios, step 1, label A, O, and H. And then we're just substituting values into SOHCAHTOA. When we use trig ratios for finding sides and angles in the next lesson, there'll be some more steps. All right, let's do one more. So let's call this one, I don't know. Let's call it SPY. And let's make it 5, 12, 13. And I want to start with angle y. So I want sine of y, cosine of y, tangent of y. I'm going to write out SOHCAHTOA. My formula for sine is O over H. My formula for cosine is A over H. My formula for tan is O over A. So let's label my A, my O, and my H. If this is the angle I'm working with, well, I always start with the H, which is my hypotenuse, the long slanted side opposite the right angle. The angle always connects the H to the A. Adjacent means next to. And the third side is the one that's opposite it, which is your O. So for sine, O over H. is 5 over 13. A over H is 12 over 13. O over A is 5 over 12. Now, I want to switch to angle S. So I'm going to do sine S, cosine S, tan S. Again, sine is always O over H. Cosine is always A over H. Tan is always O over A. Since I'm switching angles, my A and my O are going to switch. Because now that I'm working with angle S, and since my angle connects my H to my A, it makes this my A, makes this my O. So O over H, why don't you try and fill in the ratios for sine, cosine, and tangent on your own. I'm not going to pause it. I'll just give you about 30 seconds for you to try to fill in the values for sine, cosine, and tangent of S. Sine, opposite over hypotenuse, 12 over 13. Cosine, A over H, 5 over 13. And tangent, O over A, 12 over 5. Something else I want to mention, I'm kind of planting the seed for a later lesson, but what I'm planting the seed towards is a very commonly asked geometry regions question. It's also a very commonly asked SAT question, so it definitely is important. Notice that sine of one of the acute angles and cosine of the other is always the same. So these are the same. And these are the same. Sine of one of the acute angles is equal to the cosine of the other. And you'll see the same thing in the first example here. Sine of x was the same as cosine of y, and cosine of x was the same as sine of y. So the sine of one acute angle is always equal to the cosine of the other acute angle. That will always be the case. And again, we're going to do a full lesson on that later on, but it was kind of planting the seed now. That's basically it. At this point, I'll go over maybe a couple of these examples with you, and then after that, I'll let you practice on your own. So this was asking for the sine of angle U. So by the way, I keep on saying sine, cosine, and tangent. So sine is the abbreviation for sine. Cos is the abbreviation for cosine, and tan is the abbreviation for tangent. So this is what they're actually called, but the symbol for them are SIN, COS, TA. It's not sin, it's sine. A lot of students say sin. No, it's not sin. It's not cos, sine, cosine, tangent. All right, so this question is asking for the sine of angle U. So I take a look at TOA, and the formula for sine is O over H. So it's asking for the sine of angle U, so I am writing the formula for sine, which is sine of theta equals O over H. So it's asking for the sine of U, so theta is just U. So I go to U, I label my A, my O, and my H. I always start with my H. H is the long slanted side opposite the right angle. The angle always connects my H to my A, which makes this my O. So O over H, 15 over 17. I'm done. Choice 2 is my answer. Label your A, your O, and your H. write down your appropriate formula, and sub in. Why don't you try number 3 on your own? The only hint I want to give you, it's asking for the tangent of angle ABC. What's the vertex of ABC? B. Actually, I'll start you off. So, Toa, label your A, your O, and your H. I'll let you do that on your own. I'll give you about 10 seconds for that. H is the hypotenuse, the long slanted side. The angle always connects my H to my A, which makes this my O. It's asking for the tangent. So TOA, tan of theta equals O over A. Theta in this example I'm just going to call B. O over A is 5 over 12, and that's it. Number 4, it's asking for sine x, and as you can see, x is right here. So please pause this, try number 4 on your own, and then unpause. Okay, now that you did number 4 on your own, label A, H, A, and O. Always start with the hypotenuse, the long slanted side, opposite the right angle. The angle always connects the H to the A, which makes this my O. So, TOA, sine, it's asking for sine, so sine theta equals O over H. Theta in this example is x, O is 28, H is 53, 28 over 53 is your answer. Okay, there's just one more example I want to go over, and that's number 5. This one's kind of a pain in the butt. First off, what we can do to make our lives a little bit easier, we have this missing side here. Well, we learned in the last lesson, and again, you don't have to do this for this question, but we learned in the last lesson to find the missing side of a right triangle, I do Pythagorean theorem. So I'm just going to do that to fill this in. I'm going to feel better about everything if I just get that third side filled in. Because for every other problem, we've had all the sides filled in. So A and B are the legs. The legs are, in this case, 4 and I'll call that x. The hypotenuse, the long slanted side, opposite the right angle is 5. 4 squared is 16. 5 squared is 25. Square root, x is 3. So, it says which equation could be used to find the measure of one acute angle. Basically, it's saying which ratio is correct. So I'm going to have to go through each one and check it out. Now, this one's annoying because choices 1 and 2 are for angle A, and choices 3 and 4 are for angle B. So I'm going to start with angle A. Label my H, A, and O. So, TOA. So sine is O over H, tan is O over A. O over H is 4 over 5. O over A is 4 over 3. Now, again, I always have to go through all 4 choices. Let's just clear some space and make this all a little bit clearer. I'm just going to keep the 3 in there. Now I'm going to angle B. So this is still my H, but since B is here and the angle always connects the H to the A is there, my O is there. Cosine, I'm just going to do it over to the left here. Cosine is A over H. Tangent is O over A. So A over H for this angle is 4 over 5. O over A is 3 over 4. So let's see what's correct and what's not correct. Choice 1 looks good. Choice 2 is not, those are not the same, that is not correct. Choice 3, it's close, but they're upside down. And choice 4 is not close. The answer is choice 1. So again, the question's kind of annoying because you're going to have to go through each choice, and it's kind of a lot of work. However, once you get these problems, you're going to be able to do it a lot quicker. Some of you might even be able to do it mentally. But for now, you have to just go through each one and see what's correct. So your classwork/homework is to finish trigonometric ratios. This is a very, very, very important lesson. We're going to build on it tomorrow. Every region, you're going to see like 8 points on this. Basically, 10% of the exam is going to be what we're doing right now in the next week or two. So it's really, 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 really important. It's not very hard as long as you learn how to do it compared to some other stuff. So again, I'm just trying to stress the importance of this lesson. Definitely a lot more important than a lot of other lessons. And what we're going to be building on the next few days is very important as well. So make sure you complete this. If you don't understand it, ask for help. Watch the video again. Refer to the key. But it's really, really important lesson. I can set up trigonometric ratios using SOHCAHTOA. And again, SOHCAHTOA is an acronym for the 3 formulas for sine, cosine, and tangent, which are listed here. Have a great day.